Okay, welcome back. In this video, we will use Boolean algebra to simplify a few expressions. We'll work through a couple of examples and I'll highlight which rules are being used. So just a quick summary of what rules we're going to use. So here are some Boolean algebra rules. These rules are based on the AND gate logic. So here are my AND gate logic rules, and here are my OR gate logic rules. So these rules are fairly simple. There are a few additional rules that are useful. Uh, this rule is also sometimes called the absorption rule, which states A or not A B is equal to A or B. And then the following two rules are called De Morgan theorem. It basically says that A or B not, so A nor B, is the same as saying not A ANDed with not B. And this one says A NAND B is the same as saying not A or not B. So our goal in this exercise is not to prove these rules, but to use these rules to simplify some expressions. So let's do a couple of examples. So here's my first example. F equals A, B, C, or not A, or A, not B, C. So let's take a look at this and we see, so how do you proceed here? So I see in the first term and the third term, there's A and C common to both of these guys. So let's bring this up on this side and take AC out. So we have A and C from this B. Up here we have A and C, and what we have left is not B. And then we'll just leave not A alone right here for now. Now if you take a look closely up here, B or not B. So we have a OR rule that says A or not A is equal to 1. So B or not B now simplifies itself to become a 1. So that's what we have here. So we have AC ended with 1 or not A. Now if we look at our AND set of rules, we have A and 1 is equal to A. So here we have AC ended with a 1. So that should give us just AC or not A. So we have AC or not A. Now, this is where it requires a little more practice to see this, but this is basically this absorption rule. Take a look at this. F equals not A or AC. Now, if I have A and I send it through a NOT gate, I get not A. If I take a not A and I send that through another NOT gate, I get A back, but I actually get not of not A. So A is the same as A with a double bar over it. So if you look at this expression right here, I have not A and A with a double bar over it. So this looks like not A or not of not A ended with C. That is very similar to this rule right here, absorption rule. So if you take a look carefully right here, so we end up with not A or C. So that's the final simplified expression for the original expression we started out with. Okay. All right, let's do two more examples. So in our second example, we have F is not A ANDed with not B ANDed with not C, or not A not B C, or not A not C. Now what should we do first? Here, it's fairly obvious that the first and the second term have a lot of things in common. First and the second term both have not A, not B. So let's bring not A, not B out. And what we end up with is not A, not B, ANDed with not C from here and C from there, ORed with not A, ANDed with not C. So we'll just leave it this term as is. Okay. Now again, using the same rules of OR, not C or C will go into a 1. And again, using the same rule, A ANDed with 1, in this case, not A, not B ANDed with 1 is simply 1. So what we end up with is F equals not A, not B, or not A, not C. Can we simplify this even further? Now mathematically, this is the most simplified Boolean expression. We could, however, take not A out of this. This is not technically simplification because we haven't really gotten rid of any variable. When we build a circuit, this particular expression might lead to a different circuit than this, but this is not really simplified from a mathematical standpoint. Okay, but so we could leave this as the final answer, or we could leave this as the final answer. Now, some of you might see that not B or not C is this De Morgan theorem right there. So you might want to write this as this. So this is yet another correct answer. So there's no real simplification happening in these three steps. It's just a different way of writing the exact same expression. Okay? Now some of you might see that this is not A ended with, let's call this BC as P. So not A ended with not P. Well, here's another De Morgan law that we might be able to use. So not A ended with, so if I call this P, so not A ended with not P is the same as A or P with a bar over it, or A nor P. So we could write this as A or BC and a bar over it. Okay, so any four of these expressions in purple are valid and correct simplified Boolean expression for this original expression we started out with. All of these are correct. Okay, let's do one more exercise. In the final example, we'll take a look at the following Boolean expression. It looks just a little more complicated than the one we started with, but it's not. So here you go. F is equal to A ended with not B, ended with, in parentheses, we have C or BD, or not A, not B, and this whole thing is being ended with C. So let's take a look. So what should we do here? So let's do first thing. Let's distribute A not B inside here. So as such. So we have A not B ended with C from this term. Here we have A not B ended with B ended D from that term. We'll leave this term alone and we'll leave the final ended C outside as is. Now if you take a closer look here, I have B not B. What's B ended with not B? B ended with not A ended with not A is equal to 0. So B ended with not B leads me to a 0. Now if I look at the AND rules again, 0 ended with anything is 0. So we have another AND rule that we can use. So this whole term will go to a 0, thus leading us to just simply A not B C. That was the first term from here. Not A not B, and finally ended with C. Let's take a look here. What can we do next? Well, let's bring in C inside. So let's distribute this C. So I have A, not B, not C. That was the first term. Ended with C, or not A, not B, ended with my C. So what can we do now? So let's take a look here. I have two C's. A ended with A is A. So C ended with C is simply C. So I have A ended with not B, C, or not A, not B, C. What can we take common here? So I see not B ended with C, not B ended with C. Let's take that out. And we'll have A from the first term and not A from the second term, or together. So A ORed with not A, and that whole thing is ended with not B, not C. So A or not A, that rule right there is equal to 1. So I have 1 ended with BC. And we are left just with not B, C. So wow, we use all four of the AND rules in this particular example. So this Boolean expression we started out with simplifies simply to not B, C.